Hi, I'm Toby Mester from data36.com, and this is the Data36 Data Science Podcast. In the very first episode, I want to answer a very simple question: what is data science? Okay, so what is data science? Well, the question is simple, sure, but the answer is rather complex. The problem is that there are no generally accepted definitions, but in this introductory podcast episode, I will try to show you many important aspects, and by the end of the episode, you will have a pretty clear mental picture about what data science is exactly. Okay, so let's start with a broad definition. It would be something like this. You have a large amount of data, and you are trying to extract something smart and useful from it. That's abstract, I know, maybe a bit of an oversimplification too. So here's an everyday example to help you understand it. And it will be an everyday example intentionally, but when you are listening to it, you will see the business parallels too. Anyways, let's see it. Okay, so I'm sure that you have seen smartwatches, or maybe you use one too. These smartwatches can measure your sleep quality, how much you walk, your heart rate, and so on. But let's take sleep quality for instance. If you check every single day, how did you sleep the night before? That's one data point for every day. Let's say that you enjoyed excellent sleep last night, you slept 8 hours, you didn't move too much, you didn't have short awakenings, and so on. That's one data point. The day after, you slept slightly worse, only 7 hours. That's another data point. By collecting these data points for a whole month, you can start to draw trends from them. Maybe on the weekends you sleep better and longer. Maybe if you go to bed earlier, your sleep quality is better. Or you recognize that you have short awakenings around 2 a.m. every night. By collecting the data for a year, you can create more complex analyses. You can learn what's the best time for you to go to bed and wake up. You can identify the more stressful parts of the year, for instance, when you work too much and slept too little. And even more, you might be able to predict these stressful parts of the year, and you can prepare yourself. We are getting closer and closer to data science, so let's go even deeper. Okay, so if you have enough data, you can discover not only trends, but correlations as well. You can check out, for instance, how your sleep quality is affected by how much exercise you get in the given week. I mean, walking, running, biking, swimming, and so on. This can also be measured by smartwatches. And a simple correlation would be to see this. On the days you took more than 5,000 steps, your sleep quality was excellent. This is more than an analysis. This can be the basis of an action plan. Let's walk at least 5,000 steps every day. Well, at this point, I have to mention that in real life, a data scientist does much more research to get a conclusion like this one, but you get the point. And there are even more levels. Just imagine the data that the producer of this smartwatch can collect. In theory, and let's not consider legal aspects for now, they could see all the data of all their customers. And with that, they can produce analysis of their data that you, a single customer, could never even imagine. Can the symptoms of depression be mitigated by walking 3,000 steps a day for most people? Are people really healthier in some countries than in others? Can weather conditions strongly impact certain social movements? And there are many more interesting questions, and these companies might already have enough data points to research these. Well, in fact, most of them are probably doing research around these questions already. And again, let's not talk about the legal or ethical aspects of these things here. I mean, these are incredibly interesting and important questions, don't get me wrong, but they could be a whole podcast episode by themselves. And maybe I will get back to them. Anyway, as you see, the more data and the more detailed data you have in a data science project, the more complex, the more exciting, and the more useful analysis and predictions you can create. In essence, this is what data science is about. Except that, of course, all this can't only be done with smartwatches and by individuals, but with many other tools that produce and collect data in many other fields of life. And data science, of course, conquered the world of online businesses first. Why online businesses? Because that's the number one place where you can collect data about every single movement of a user. And again, I know some companies, of course, abuse this opportunity, but again, we don't dive into the legal or ethical aspects in this episode. Anyway, I also have to mention that parts of data science have been present in different social sciences for decades. And in the last few years, it started to gain a foothold in fields like manufacturing and production, agriculture, logistics, politics, automotive, and many more fields. But the number one field for data science is still online businesses, and I will get back to it in a few minutes, and I will give you a few real-life examples of how data science can be useful. But before that, I want to talk about what skills and what tools you need to do data science. Okay, so if you have ever read my blog, data36.com, I'm pretty sure that you have seen this Venn diagram where I have three bubbles: statistics, coding, and business, and data science is basically the intersection of these. I show it quite often, and it's really important, and so it basically says that if you want to be a data scientist, you have to be good at these three things. Again, it's statistics, coding, and business thinking. And why are they so important? Well, let's see them one by one. Okay, first, coding. And coding is inevitable because that's the tool you need to work with your data. It's like the piano for the pianist, the brush for the painter, or the pen for the poet. If you want to make your ideas come true, you have to know and use your tools as a professional. The most popular data science languages are SQL, Python, R, and I want to add one more to this list. It's Bash. I won't go deeper into this right now, but I write about all of them on my blog. You will find links in the show notes, and if you subscribe to my newsletter, you can also get access to free cheat sheets and video courses. So if you are interested in that, just go to data36.com/newsletter and subscribe. Anyway, that's coding. The second important skill is statistics. And I always say that statistics is the actual science of your data science projects. After all, data is about numbers, right? And when you work with numbers, you should be confident with mathematical and statistical concepts. And I know that many people are afraid of statistics, or even more, they hate statistics, but statistics is not boring nor extremely difficult. It's only that it has a very bad marketing, if you know what I mean. But to become a data scientist, you have to be familiar with statistical concepts like statistical averages, statistical biases, correlation analysis, probability theory, functions, machine learning algorithms, of course, and so on and on. Again, I write about this on my blog. Maybe I will publish a few podcast episodes around these topics as well, but statistics is important. The third big topic, the third big skill you need is business knowledge or business thinking, sometimes referred to as domain knowledge, and this is a soft factor. For example, let's say that you are working for a bank as a data analyst. You can be the best coder and the best statistician, but if you don't understand the business concept behind interest rates or how mortgages works, you will never be able to deliver a meaningful data analysis. So again, data science is an intersection of three things: statistics, coding, and business. And of course, to be successful in the long term in data science, you have to build other soft skills like presentation skills, project management skills, and people skills, but let's not go into this for now. Let's talk about a very important other topic instead, about all the buzzwords: machine learning, AI, deep learning, predictive analytics. And I wish I had $1 for every time when mainstream media misinterpret the different data science related terms. Because, machine learning, artificial intelligence, deep learning, predictive analytics, well, in everyday use, they are buzzwords. But in data science, they have real meanings and a certain place within the field of data science. So it's time to clarify what means what. So let's start with the most basic one, data analysis. The word data analysis refers to the most conventional way of using your data. You run analysis to understand what happened in the past and where are you now. For instance, let's imagine a line chart that outlines the last 24 months of your product sales. That's data analysis. Okay, and what is predictive analytics? Now imagine the same line chart, but this time you use it to predict the future. So you will answer the what will happen question instead of the what did happen question. And the easiest and most common way of predicting sales based on a line chart is obviously fitting a trend line that you can do in Python, for instance, but sometimes even in Excel. And of course, there are much more complex methods and algorithms in predictive analytics. But let me mention here that even fitting a trend line isn't that simple, because you can fit a straight line, or you can fit a polynomial, or you can fit a logarithmic function or an exponential, and it's not really self-explaining. And also, the best fit quite often doesn't lead to the most accurate prediction. So when you ask what is data science, most data scientists would say that predictive analytics is where the science part of data science starts. So predictive analytics is not easy, and I will get back to it in another episode. But let's go to the next concept and let's talk about what is machine learning. So let's stick with the line chart example. And when a computer fits a line to a line chart, for instance, it tries to find a mathematical formula that describes well enough the relationship between the real-life data points. These real-life data points usually have a natural variance, so that's why a sales line chart goes up and down. And so you might ask, how the heck can a computer find the mathematical formula to describe something that has natural variance? And the answer is machine learning. Machine learning is the general name for all the methods by which your computer fine-tunes a statistical model and finds the best fit for your dataset. And again, the line fitting example is only one of many. There are tons of machine learning methods for all the different typical data science problems. This model fitting machine learning method is called, by the way, regression, or more precisely, it can be linear regression or polynomial regression and so on. But there are classification problems. The popular machine learning algorithms for these are decision tree, random forest, logistic regression, and so on. There are clustering tasks, and many, many more. I won't go into detail here. Again, this is an introductory episode, but you will find more about these on data36.com. And let's go to another popular buzzword instead, which is deep learning. And deep learning's gotten very popular in the last few years, but many still don't know what it is and what is it good for. So deep learning is nothing but one specific machine learning method, as I said. And as I also mentioned, there are a lot of machine learning models, and all of them are good for solving different data science problems. Deep learning is only one of them that's recently been widely used for image and voice recognition projects. The way it works is quite interesting, by the way. It gets input values and it turns them into output values after filtering through many layers by creating automatic correlations. And the interesting thing in it that it works very similarly, at least on the concept level, to how the human brain works. The best example and explanation of deep learning that I've heard so far was by the director of AI at Tesla. And in his presentation, he introduced how Tesla cars learn to drive. And he also explained the general concept of deep learning, and he showed how they are using it. It's part of a bigger presentation, but I will link the video in the show notes, so check that out if you are interested. And let's head over to another popular concept called artificial intelligence, or AI. And oh boy, well, when I drafted this podcast episode, I wrote a long paragraph about incompetent wannabe data professionals, clickbait journalists, and ignorant managers who read articles from those clickbait journalists, by the way. And of course, about companies who try to market their simple database products with the AI tag that recently sells everything, but I just deleted it because I don't want to offend anyone. It's enough if you know that AI, artificial intelligence, doesn't exist yet, and if humanity does ever create one, it won't happen in the next few years. As of 2020, there is no computer that would be capable even of imitating creativity, intuitions, ambitions, inspiration, or anything else that makes us human. I mean, sure, there are very advanced bots, like the one that Google presented in 2018. I will link the video in the show notes again. But if you think about it, most of these AI things are nothing but a combination of an advanced chatbot, an advanced voice recognition software, like the one that you have in your smartphone as well, and an advanced speaking engine. And I also have to mention that most of these bots, called AIs, work only in very narrow situations. As soon as they fall off their original script, they are useless. Also, show me an AI that has its own ambition to learn, I don't know, Chinese or Spanish, because it feels that it will be important for its career, right? Today's AI is not even close to real human intelligence, and I'm not saying it won't change in 5 years or 10 years. I just don't like that many things are sold with the AI label. Anyway, I thought about it too much, and I want to talk about one last thing in this introductory episode, which is data science project examples. Okay, so far I thought about the theory of what data science is, but you might ask that how will all this get useful and profitable for your business? And there are so many ways that it could benefit this episode, but I will talk about 5 examples to give you a few ideas at least, and I will add more in later episodes, but I will start with a super simple example, which is a classic data project in a classic online business. And let's say that you have an e-commerce business and you want to create reports for internal usage. Many companies are doing this, by the way, although whether they are doing it right is a whole another topic. So anyway, in a project like this, e-commerce business creating reports for internal usage, the goal is always to help the decision makers and managers see more clearly before they make an actual decision. And the job of the data scientists and analysts is to provide analysis, reports, and charts supporting these folks. The data scientist goes and checks out what happened in the last few weeks, months, or years, what are the trends, what changed, what is the typical customer journey, what can we expect in the future based on the data from the past, and the management makes decisions based on this. Let's say that we see that people are buying more and more red sweaters and fewer yellow t-shirts. Obviously, you will try to align your offers with these trends. This is a that simple example of using data in a business, yet done right, it can provide a lot of value. I mean, it's simple to talk about, putting it into practice is always harder. The devil is in the details, you know, but that's true for sure that at e-commerce businesses there are many opportunities to take advantage of the data they have. So my second example is a slightly more advanced and complex data science project, but we are still looking at the very same e-commerce company as in the previous example. But now let's focus on the advertising costs. For the sake of simplicity, let's talk about Google Ads only. Let's say you get a question from management, what should our budget be in the next quarter for Google Ads? And it's not so simple to set the right value. If the budget is too high, that's not good because you will overspend and the profit will start to go down. If the budget is too low, on the other hand, that's not good either because then you don't spend enough money on advertising. Sales go down, so does income, so does profit. So, got the problem? You need to find the perfect balance. And this is where data science comes into play. The data scientist will know how to estimate the optimal spending limit that results in the most profit. I mean, at many companies, a senior marketing manager can do this as well, based on best practices and industry benchmarks, even in spreadsheets. and sometimes with pretty great results. But data science offers an even better and more precise solution by using machine learning and predictive analytics. Let's see the case. The data scientist of this company will work with data from the last few years. This can include cost, income, website traffic, sales, and many other input variables. Using these data points from the past, the data scientist tries to fit a machine learning model to the dataset. Eventually, she will get a mathematical model that she will be able to use, creating a super accurate prediction and eventually an optimal budget for the next quarter. And this is great because it's more accurate compared to the manual, human-created predictions, but it's also more scalable. You can always make these things more complex by including 6, 8, 10, or even more marketing channels where you can spend money on advertising. A human would struggle with maintaining an overarching view of all these, but for a computer and the machine learning algorithm, that's just another few variables, another few dimensions in the formula. And I'm not saying that every company should build their advertising budgets on data science and machine learning, but there is a certain size and complexity above which it is extremely profitable. My third example is a grocery store's data project. So food is usually not a long-lasting product, right? And I've heard this from a friend who works for a well-known grocery giant as a data scientist. For big grocery stores and food companies, predicting how much of different products they should order and stock is a huge challenge. It's the same problem as in the previous example. If they order too much food, it goes bad on the shelves. If too little, they won't have supply and their shoppers will be dissatisfied, or even worse, go to a competitor. Either way, they realize a loss. The only way to win is to find the perfect balance. The solution for this problem can again be a fine-tuned predictive analytics model that makes predictions based on past data. This can be done based on multiple input variables by using mathematical models, but once you can predict the demand, it becomes much easier to align the supply. By the way, data science is quite popular in this segment as well. For instance, there are a lot of cool stories about how Walmart predicts trends and finds correlations between different variables in their business. Unfortunately, I can't really find trustworthy resources on this topic, so I don't know whether Walmart has really done this or these are just urban legends. But one thing's for sure, with the technology we have in 2020, these data science projects could be done easily. Anyway, one of the most popular stories was that Walmart found correlations between weather data and sales. They have seen that when huge storms are coming, their customers start to buy more raincoats, flashlights, and wait for it, beer. So data says when the weather goes really bad, next to the flashlight stocks, they will have to double up on beer supplies too. And there are multiple combinations of these case studies with correlations between diaper and beer sales, or predicting a customer being pregnant before she even knows, and so on. As I said, we don't really know whether these stories are true or not, but it's certain that Walmart sells millions of products in thousands of stores all over the world. That means lots and lots of data points. In other words, a great opportunity to create business value using data science. My fourth example is one that you too might know very well, the recommendation engine of YouTube. Every time you watch a YouTube video, in the top right corner, you will see a recommended next one. And this is totally automatic and data-driven. YouTube uses a method called collaborative filtering to do it. In a nutshell, it works like this. First, they check out what videos you have watched before. 2, they check out other YouTube users who watch the same video as you. 3, they list what other videos these other users have watched. 4, eventually your next recommended video will be the one that those other similar to you YouTube users watched right after the video you are watching right now. The theory sounds simple, right? The actual implementation of a recommendation engine like this one is rather complex, of course, but this is just another great example of how data science can help businesses to keep their users, visitors, and listeners on their website. I have to add that almost all media platforms use similar methods like Spotify, Netflix, some news portals, and so on. And my fifth and last example in this episode is something that's a bit further from the small and medium business segment. It's self-learning robots. If you don't know what I'm talking about, check out the video in the show notes about Boston Dynamics, who have created pretty human-like robots. And these robots are super intelligent and skillful. They can act and react to many things like a human would do, and the greater part of their intelligence comes from data science and machine learning. Image and sound recognition engines, self-learning algorithms, neural networks, and many more advanced data science concepts move and improve these machines. And of course, Boston Dynamics is not the only company that experiments with these futuristic technologies. Self-driving cars, human-like robots, and many other inventions are based on the very same principles, and these are the things that are the closer to the thing that we call AI or artificial intelligence today. In my opinion, we still cannot call them yet artificial intelligence, but let's not get back to there. So these were just 5 simple examples to give you a taste of how data science can be good for a business. And with that, I would like to wrap up this introductory podcast episode. And I hope that everything that I talked about here helped you to clarify what data science is. I know for some of you this was very introductory, but again, the problem with data science is that there are no generally accepted definitions, and there are many layers of it, and I just try to show you as much as I can in one podcast episode. I hope you enjoyed it and that you learned a lot. And if you want to learn more, feel free to subscribe to this channel. All podcast episodes will be available in all podcast applications. So anywhere you are listening to it right now, feel free to subscribe. And the best way to get notified about new episodes is always the Data36 newsletter list, the only place where I really communicate to my audience. And you can subscribe to it at data36.com/newsletter. And if you do so, you will get access to a lot of free learning materials too, including my free mini course called How to Become a Data Scientist. So check it out and subscribe, data36.com/newsletter. You can also check out the website, data36.com. I have a lot of articles, including learning SQL from scratch, learning Python from scratch, statistics articles, and many interesting things that can help you to get started with data science. Anyways, thank you for listening. I'm Tomi Mester. This was the first episode of the Data36 Data Science Podcast, and I thought about what is data science. Thank you for tuning in, and hopefully see you in another episode.